Hi, welcome to Math at Home with Mr. Harrison, the holiday edition. The boys and Mrs. Harrison and I just finished decorating our Christmas tree, and I'm feeling very much in the Christmas spirit, and I thought what a great time to do some math. So parents, if you're watching with your kids, we're going to be talking about factoring a number, which is finding all of the factors that can be used or multiplied together to create that number. We're going to start with this number right over here, 12, and we're going to make what's called a factor rainbow. Any number can be divided by 1, so 1 is a factor of any number. So 1 times 12 is going to equal 12, because 1 times any number is itself. So for 2, we're going to go up here to our divisibility rules, and it says 2, is it even? Is the number even? And yes, it is, so yes, it is divisible by 2. So we're going to put a 2 right here, and we're going to say to ourselves, what times 2 equals 12? And we can say 2, 4, 6, 8, 10, 12. That's 6. 2 times 6 equals 12. Now for the number 3, we look and we say if the sum of the digits is divisible by 3, the number will be, 3 will be a factor of the number. It will be divisible by 3. So 1 plus 2 equals 3. That is divisible by 3. So we're going to put our 3 right here, draw our rainbow, and to figure out what that magic number is, we're going to say 3, 6, 9, 12. It's 4. So we're going to put a 4 right over here. Now for 5, it says if there's a 0 or a 5 in the ones place, then 5 is a factor of that number. But there is not. So 5 is not a factor of 12. You can prove it. 5, 10, 15, whoop, blew right past 12. No 5. What about 6 though? 6 says if it is divisible by both 2 and 3, which we have 2 and 3 as a factor, so yes, 6 is going to work. So we're going to use 6 as a factor, and what times? We already have 6. See what I did there? We already have 6. So we're done. We are back to the other side of the rainbow. So our factors for 12 are 1, 2, 3, 4, 6, and 12. So that takes care of 12 for us. So let's try another number. Give me just a second to erase. And we're going to try a little bigger number. We're going to try the number 57. Now if you're watching this and you're in my class, you know that we listed this as a prime number. And then we discovered that it is not a prime number because of our divisibility rules. So let's start with 57, okay? We're going to always start with 1, and 1 times 57 equals 57. 2, well, it has to be even. It is not. It's an odd number, so 2 is out. 3, if the sum of the digits is divisible by 3, the number is divisible by 3. 5 plus 7 equals 12. 3, 6, 9, 12, yes. So we are going to put a 3 right here, and now we have to figure out how many 3s it takes to make a 57. And to do that, we're going to have to go to our old friend long division. We like to do long division, right? So we remember that Dad says divide. We're saying how many 3s can I fit into a 5? Just 1. Mom says multiply. 3 times 1 equals 3. Sister says subtract. 5 minus 3 equals 2. Brother says bring down to 7. Rover the dog, he says repeat. So Dad says how many 3s can I fit into a 27? We know our multiplication tables. We know that that's 9. And then that's going to equal 27 when Mom multiplies. When we subtract down to 0. There's nothing else to bring down. This is our answer, 19. Alright, now we look at 4. If the last 2 digits are divisible by 4. Well, they are not. What about 5? Well, no 5, no 0 here. 6, it was not divisible by 2. It must be divisible by 2 and by 3. So 6 is out. 7 we don't really mess with a whole lot, but we can look at it this way. 7 times 7 is 49. 8 times 7 is 56. And 9 times 7 is 63. And 57 lives in there in the middle somewhere. We did not land on that. So 7 is out. 8 says if the last 3 digits are divisible by 8, and they are not. So 9, well, you would think it's divisible by 3, it would be divisible by 9, but if the sum of the digits are divisible by 9, is divisible by 9, sorry. So 5 plus 7 equals 12, and that is not divisible by 9. 9 is not a factor of 12. If we count by 9s, we say 9, 18, boom, right past 12. So this is it. This is the list of our factors. Our factors are 1, 3, 19, and 57. There are 4 different numbers you can use as a factor to get to 57. Let's try another one. Let's try 63. So, we'll try 63. And of course, we always start with 1 and 63 because that's the easy one, we know that. 2, is it even? No, it is not. It is an odd number. 2 is out. 3, is the sum divisible by 3, the sum of these 2 digits? Well, 6 plus 3 is 9, and yes, that is divisible by 3. So we're going to put a 3 right here and draw a rainbow over here. And now we've got to figure out how many 3's make 63. And a quick way to do that is to say to yourself, well, I can fit 2 3's into a 6 and 1 3 into a 3, 1 3 into a 3, and that gives me 21. Now a quick check on that would be to do a multiplication. 3 times 1 is 3, 3 times 2 is 6, boom, done. So we are good there. Now 4 says if the last 2 digits are divisible by 4, which they are not, and 5 says that it must be a 5 or a 0 in the ones place. It is not. 6 says it must be divisible by 2 and 3, and it's not divisible by 2 because it's odd. And 7, well, we're going to have to take a look at 7. And there's a divisibility rule for 7, but it doesn't really make life any easier. Knowing your multiplication tables makes life easier. So we're going to look at our 7's. So if we do our 7's, we say 7, 14, 21, 28, 35, 42, 49, 56, 63. We landed right on it. Where did we do that? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we're going to have to list 7, right? And we could have skipped 7 and gone right on to 8 and then to 9. And if the sum of the 2 digits is divisible by 9, and we know that it is, so 9 is going to be in there. And of course it's not divisible by 10 because there's no 0 in the ones place. And so that is our factors for 63. 1, 3, 7, 9, 21, and 63. There are 1, 2, 3, 4, 5, 6 factors that can be used to make a 63. Now the fun thing about this is that you don't need Mr. Harrison to give you numbers to do this with. You can pick any number, and you should be able to factor out any number between 1 and 100. So just pick a number, and you try it yourself. Try factoring it out yourself. And of course, if you have trouble and you don't know how to do it, be sure to give me a call or talk to me about it in class tomorrow. Or if you're watching this in class today because you need a little bit of help, put your hand up, and we will make sure that you understand how to do this. This is going to become very, very important as we move into fractions. So thank you so much for watching, and we'll see you next time on Math at Home with Mr. Harrison.